Ampere's force law describes the experimentally derived fact that for two thin, straight, stationary parallel wires, well, that is quite the constraint, I guess, that are a distance r meters apart. Let me just try and visualize this. So we got two straight, thin, parallel, stationary wires. So the distance r meters apart, in each of which a current of I amperes flows. So I is representing the current there. So in which a current of I amperes flows, the force per unit length, which they are giving me, they're actually giving me force and then per length, which is fine, measured in units of kilograms per second squared, is proportional to I squared over R. Determine what the units of the proportionality constant must be. Okay, so actually I don't really need the picture. I don't need to understand what's going on. We have different expressions here. So they're saying force per unit length. So force, incidentally, force should be what? Kilogram meters per second squared. And then they're dividing by length, so that gets rid of the meters. So we've got this is proportional to the current squared, so the current is measured in amperes, per R, or divided by R, which is measured in meters. Okay, so when we say something is proportional to, what that's really meaning is there is some constant, we don't know what it is, but we'll call it K typically, so that if you multiply the one side by K, you can actually replace the proportionality symbol with an equal sign. And so ultimately, it's quite a wordy question, but ultimately what this question is saying is, what are the units of this mystery K value? Okay? And so they're already being nice. They give us the units on the left-hand side, kilograms per second squared. And those are going to be whatever the units of K are, times, well, what are the units of current? That's amperes. So amperes squared for I squared per, and then it'll be meters for the R, because R, they're saying, is measured in meters. So if we want the units for K, we can just go ahead and rearrange this. So this will be kilograms times meters divided by second squared divided by amperes squared, and those are the units of this mystery constant K. So there we go. It wasn't that bad of a question. It was a wordy one. I completely agree. But there we go. Kilogram meters per second squared, amperes squared. If you want to go further with it, I think this is like this. This is newtons. So if you wanted to say you could do newtons per ampere squared, there's probably a couple other ways to arrange this involving other units like henries or something like that. But there we go. Just in terms of the units we were given, those should be the units of this proportionality constant K.